Hello and welcome to 11.3 Compound Interest. Investment, the use of money or capital for income or profit. Fixed investment, the amount invested as principal is guaranteed and the interest is computed at a fixed rate. But in variable investment, neither the principal nor the interest is guaranteed. Compound interest, interest that is computed on principal and any accumulated interest. So that's interest on interest. That could be good, that could be bad. So Marty won $1,000. She deposits $1,000 in a one-year CD paying 2.5% compounded quarterly. Find the amount A to which the $1,000 will grow in 1 year. So first quarter, or 4 quarters in a year. The interest is 1,000 times the 0.025 interest rate times 3 months out of 12, or 1/4 of the year. And that's 6.25. So she now has 1,000 plus 6.25, or $1,006.25. For the second quarter, the interest will be 1,006.25 times 0.025 times another 3 out of 12 months. Now the interest is 6.29. Look at that. Interest went from 6.25 to 6.29. So it's 1,006.25 plus 6.29. And that is 1,012.54. Now we'll go on to the third quarter. The interest is going to be 1,012.54 times 0.025 times 3 out of 12. The interest is going to accrue to be 6.33. So now we're at 1,012.54 plus 6.33 is 1,018.87. So we're getting interest on interest. That's kind of cool the way it grows. Fourth quarter, the interest is going to be 1,018.87 times 0.025 times 3/12. And that is $6.37. So 1,018.87 plus 6.37 is 1,025.24. Now if we didn't do that, if we didn't compound that, the interest would have just been 1,000 times 0.25 times 1, or $25, so it would be $1,025. By doing the compounding interest, you got an extra 24 cents. I know it doesn't seem like a lot, but no extra work was done on her part, and she got more money. Now you're probably thinking, hey, isn't there an easier way to do this? That's kind of tedious. What if I'm doing this like 1,000 times? What if we have all these compounding periods? Yeah, there is an easier way. Right there, the compound interest formula, where A is the amount, P is your principal. So the amount equals principal times 1 plus R over N to the NT power. So the amount is the principal times 1 plus R. R is your interest rate in decimal form. N is the number of times per year you're going to compound. Could be once, could be 4, could be 12, could be 52, could be 365 to the NT power. T is time, how many years? So I'm going to scroll this up. When Matt was born, his grandfather invested, I wish I could get this up a little bit, $2,000 into a money market account paying 4% compounded monthly. How much will Matt have at age 18? So the amount's going to be that $2,000 times 1 plus, the rate is 4%, so 0.04 compounded monthly, that's 12 times a year, to the power 12 times 18. If you're doing this in the calculator, amount equals 2,000 times, parenthesis, 1 plus 0.04 divided by 12, close parenthesis, caret button, or y to the x, whatever you're using, parentheses 12 times 18 is the best way to do that. Make sure this power is in parentheses, otherwise it'll raise it to the power of 12, then multiply that result by 18. Anyway, this comes out to be $4,103.95. When we're dealing with money, we typically round the final answer 2 decimal places. Okay, effective annual yield, or annual percentage yield, the simple interest rate that gives the same amount of interest as a compound rate over the same period. So often you see banks and they'll have signs about talking about the yield. That's what it's talking about, is what would the equivalent simple interest rate be? Okay, example 3. Determine the annual percentage rate or percentage for $1 invested for 1 year at 9% compounded daily. So the amount is 1 times 1 plus 0.09 divided by 365 to the 365 times 1. That's 1.09416, excuse me. So if you subtract off the 1, you end up with 0.09416, and that's 9.416% annual yield. In the second case, compounded 7% compounded monthly, do $1 again. 1 times 1 plus 0.07 over 12 to the 12 times 1. That's going to be 1.0723. Subtracting off the 1, it's 0.0723. That's a 7.23% annual yield. And because sometimes it's compounded daily, sometimes compounded monthly, sometimes compounded continuously, it's good to be able to compare this apples to apples, so to speak. So we're talking, there it is for that one, here's for this one. Going daily, it bumped up from 9 to 9.416, going monthly from 7 to 7.23. Present value, the principal invested now to have a certain amount at the end of the period. So really, it's our formula, if we solve for P, it's the amount divided by 1 plus R over N to the NT power. Vince and Jessica just had a baby. How much should they invest now at 5% compounded monthly to have $20,000 available for college in 18 years? So the present value, what we're trying to find out, P equals the future amount that they want to have divided by 1 plus 0.05 is the rate over 12 to the 12 times 18 power. And in the calculator, this looked like 20,000 divided by, parentheses, I do double parentheses, 1 plus 0.05 divided by 12, close parentheses, caret button, parentheses, 12 times 18, close, close. This comes out to be $8,146.61. Okay, that'll do it for 11.3. I hope you enjoyed compound interest. Send me your questions. Thanks.